This is Tom Levine, Cornerstone's tech guru. It is 9:30, so we're going to go ahead and get started. Welcome to the presentation on 4G and 5G. This one builds on our last presentation, by the way, on Wi-Fi and networking. So if you haven't watched that, no worries. We're still going to cover everything about generally how networking works, but if you'd like a more solid background, I'd highly recommend you go and check out our last Tech Tuesday on Wi-Fi. Today we'll be covering 5G and 4G LTE, as I mentioned. If you have any questions as I go through this, please feel free to type it in the chat bar or in the questions section of this presentation, and I will get to it at the end of the presentation. So I will be answering all your questions, don't worry. Just some bookkeeping things I need to take care of before I get started here. If you haven't checked it out already, I would highly recommend you check out Cornerstone's Resource Center. You can go there and look at all of our recorded webinars, not just Tech Tuesday, but that includes all of our Build Your Brand sessions and all of our new business resources. So I'd highly recommend you go on our website under resources and see what's there. You can also go there to register for future webinars as well and print out a lot of customizable ready-to-go marketing materials for free. Doesn't require a password, and you can email me or call me with any questions you might have about that. Additionally, we are still doing our Cruise in the Caribbean sales contest. The qualification period on new sales for that is January 1st to December 31st. If you're interested, there are a few more details online at www.crnstone.com/cruise-2020. So that being said, we're going to cover a little bit of networking today, and don't let that word scare you. The networking that I'm referring to is Wi-Fi specifically and the internet. We're going to cover the differences between homed networks and wireless data. So that includes your phone. If you have a hotspot, it'll cover what the difference between that and normal Wi-Fi is, the cost differences associated with these things, how to compare data transfer speeds, as well as what G means for 5G, 4G, 3G, and those kinds of things. You might have already heard 5G being mentioned online, or if you've seen any recent Verizon commercials, Verizon has a 5G network now. So what exactly is the difference between those, and why would I switch? That's one of the things we try to get to the point of in this presentation. So let's get started. First off, in order to understand the difference between wireless and wired networking, or home and mobile networks, you're going to need to understand a little bit more about ISP services and rates. An ISP, or Internet Service Provider, connects your home devices through a router and modem to a wide area network. We covered this in the last presentation, so I'm using a bit of jargon too, by the way. Wide area network just refers to your carrier, so your carrier's network of computers. What you would pay for on a wide area network or ISP plan is the speed. You basically pay for priority access to their services. A WAN uplink is a cabled connection, so it connects your home to a internet service provider through a cable. That cable is probably either underground or on telephone lines, so you don't typically see it that often. But they also can access any computer that is on their network for free. So when you sign up for a carrier like Sprint, or well, not Sprint, but Spectrum, then they're able to access any data on your computer that's available on the World Wide Web for free. They are only also charged a small fee to access content that are stored on other wide area networks. So if you had a Spectrum connection and you were trying to access a web page that was hosted by Cincinnati Bell, Spectrum would pay Cincinnati Bell a small fee to access that content. And you don't see that at all because of how small it is. Like I said before, if you're paying for ISP service, they can generally access most content on the web for free or next to nothing. So that's why you're mainly paying for speed on a wired connection. That is very different when it comes to mobile computing. Carriers use radio towers to connect devices. So if you're on Verizon or Sprint or AT&T, when you try to connect to the internet, you're actually connecting through wireless signals. You're not actually hitting a wired line for your data. Because the towers communicate with radio waves and few to no cables, there are severe limits to speed, and you can't charge for speed like a carrier would. Additionally, the limits are mainly because they're being transferred with radio waves and not electrical signals. A radio wave has a fixed amount of information that it can send back and forth through each wave. This means that if you're trying to up the speed of a network, you need to get more wavelengths of radio waves. That's called bandwidth, by the way. The more bandwidth you have, the faster you can transfer things and send data. It's kind of a similar limit on the speed and transfer rate as Wi-Fi has, except carriers use much higher powerful radio waves that can travel longer distances. So, why are you charged for data usage from your carrier, but speed with your ISP? There's only so much bandwidth available to use. You can only send so much data over that specific bandwidth at any one time. So the more data you use, the more bandwidth your carrier ends up needing to purchase in order to send those signals at higher speeds. And wireless carriers also don't have many wired networks of physical computers. Remember back when I was talking about ISP service, I said that carriers, or not carriers, but ISPs can generally access each other's data for a very low fee. That does not extend to wireless networks. Carriers such as Verizon or Sprint have to pay every single time you access a web page because they don't host anything. They don't have any solid computer banks that have web pages stored on them. I'm not exactly sure which big companies use what carriers to support them or what ISPs, but because of the way they're networked, an ISP doesn't really have to pay a large fee. But with a carrier, every time you access Facebook, every time you get on YouTube, every time you access the internet, they have to pay a decent chunk of change, which is why you pay per data rate versus per speed. That's just how the math works. Your monthly cost that you pay to your carrier pays to offset the fee they pay to wide area networks to access the websites, and it also goes to offset how much bandwidth they have to purchase to send and receive your data. And I know that sounds like a lot of jargon, but it can be basically summarized like this. The more internet you use, the more it costs a wireless carrier versus a wired connection doesn't really cost them anything. So that's why you have to pay per data used, not by wired rate. So what's the difference between Wi-Fi and a hotspot? They connect to your device the same way. Both use radio waves to connect devices to each other and to the internet. However, Wi-Fi uses a router connected to a cable connection or an ISP network. Hotspots are connected to your carrier's network. So a hotspot is like Wi-Fi, but connected to Verizon or connected to Sprint. That's really the only difference. They eat up a lot of bandwidth. So unless your carrier is a large one, like Verizon or AT&T, with a lot of ISPs like under contract, your carrier probably won't actually offer a hotspot, or if they do, they're going to offer it at a very limited amount, or it's going to be very costly just because they don't have those kinds of agreements with other large carriers. So that being said, what's better? What's faster? A mobile network like a home AT&T or Verizon box, or an actual home network, or just the G systems in general? In order to know that, we're going to have to use math. Do not get freaked out. I will walk you through all of this, I promise. We're going to be covering basics of the metric system. We're going to be covering the differences between bits and bytes. It's going to be very science and math heavy, and I'm going to go very slowly. So don't worry if you're one of those people who get freaked out by math and numbers above other numbers. So first, we're going to cover a bit of the metric system. Metric basically uses prefixes that go up by factors of 10. It begins at 1 unit of measure, like a meter is 1 meter. A kilometer, after that, if you take a look at the table, is 10 to the third. So it's 1,000 meters because it's 10 times 10 times 10. Next is mega, and then giga, which are the ones that we typically use in computing. Megabyte is 10 to the 6th bytes. A gigabyte is 10 to the 9th bytes, and that is a very big difference. Remember, each one of these powers is an additional factor of 10. So we go from 1,000 to 1 million, and then up even higher for giga. Here's just a general example of how you would convert between the two. If we have 1 kilobyte, that's equal to 10 to the third bytes. So 1 kilobyte equals 10 times 10 times 10 bytes. So 1 kilobyte equals 1,000 bytes. It also means that 1 byte is equal to 1/1000th of a kilobyte. So what's the differences between bytes and bits? That's probably not a question you've ever asked yourself, but a byte is equal to 8 bits. And 8 bits are also, by the way, what can be maximum carried over 1 bandwidth, or 1 little wave of bandwidth. Bytes measure file size, but bits are used to measure transfer speeds. So you need to convert between the two in order to really compare the differences in speeds that you see, unless they're both in the same unit of measure. A lot of times carriers will switch this up on you. So it's a way that they sound fast without actually being faster if they're comparing bits and you're trying to compare in bytes. So that's why I mentioned this. You can also tell on paper because they're notated differently. Bytes is a capital B and bits is a lowercase b. Typically, you'll see it notated like 10 MB or 10 megabytes for a file size. And then 10 Mbps, BPS in lowercase, is megabits per second. And that means they're transferring at a rate of 10 megabits per second. So an ISP typically also measures in megabits per second, but a lot of times nowadays they will actually measure by megabytes per second just to up their overall rate and display it in a lower value. So it's just something to look out for. If you're looking at a rate in megabytes per second, the B will be capitalized in the Mbps kind of layout. An ISP connection has a download speed of at least 100 megabits per second, which sounds kind of slow, but that's honestly the lowest value I could find to start comparing. A lot of people probably have somewhere in the 300 megabit per second range with a wired line. The average download speed of a carrier network, however, is 32.375 megabits per second, which is only about a third of that. That being said, if you're using Wi-Fi on a wired line, you're probably getting about the same rate because they're both communicating using radio waves. That's one of the differences between a wired connection for the internet and a wireless connection for the internet. Verizon, however, is actually leading the pack with internet speeds right now. Their normal 4G download speed is 53.3 megabits per second, which is pretty impressive, actually. It's amazing that they managed to get that much bandwidth. So what does that really mean, though, in terms of speed? We can actually check this out and use conversions and math to figure out how many seconds it would take to download a general file. If you're trying to transfer 60 megabytes like you're using in this comparison, the math gets kind of easier, but I know it probably looks like a bunch of jargon to all of you. So let me kind of walk through it. The formula is we've got to take megabytes and turn it into bytes, then bytes to bits, and then divide all of that by the total rate that we're transferring the file at, which means we do 60 times 10 to the 6th first, then we multiply that answer by 8, and then divide all of that by the speed of the transfer, which on Verizon, if we calculate it out, equates to 9 seconds. And the easiest way to see this calculated is actually to get out a calculator and go through it step by step. Remember PEMDAS, which is parentheses, exponents, multiply, divide, add, subtract. That's the order of operations that you use when going through a formula like this. And you always start with the innermost quotations. So it would be 60 times 10 to the 6th first, then that answer multiplied by 8, divided by your total data transfer speed. And that's how we calculated that 9 seconds out. Comparing that to an ISP's slowest speed, it would download the same file in 4.8 seconds. So the difference is about 4 seconds approximately, which doesn't sound like a lot, but you'll see why when we get into 5G's comparison. Speaking of G's, that just stands for generation. The generations of wireless communication are actually defined by a standard setting organization. It is called the 3GPP, and it has 7 associations that are all joined together under it that sort of enforce the standards that it applies. These associations are from all over the world. So a 3G network in Singapore is the same as a 3G network in America. It determines exactly what defines each network or generation of network, but mainly the difference is the amount of speed that you're transferring data. To see the difference, let's compare 3G to 4G, which actually happened fairly recently. 3G speed was actually rolled out around 2008. It was a set milestone. We didn't actually hit this until last year. Well, actually, I mean 4G until last year being the new speed standard, but 3G is really the start of wireless computing and wireless networking. The peak data speed was about 200 kilobytes per second, and it used enough speed to use a navigation app with a little bit of delay. That's when 3GPP rolled out the 4G standard, in 2008. That was set as the next milestone, but they didn't expect it to be hit quickly. The peak data transfer speed had to hit at least 100 megabits per second versus kilobits per second. That's an 800 kilobyte per second difference, by the way, because kilobytes to megabytes is 1,000. That's just the overall difference in their powers through the metric system. The difference in speed means that you're able to stream video and music without buffering while also using other apps, including navigational apps. And this is a very difficult challenge to meet using current wireless networking technology. So, like I said, it was released in 2008 to improve the 3G standard. It really took us 10 years to fully meet these standards. 2008 was really or 2018 was really the benchmark where almost all major networks are consistently hitting 4G. That means Verizon, Sprint, AT&T, and I believe one other carrier have all hit those rates consistently. So now those are qualified as 4G networks. They actually had a limited rollout of 4G LTE, which was a stopgap. It wasn't fully hitting all the standards to be considered 4G. They had certain areas of their network that had a lower speed, and 4G was really only available in cities about 2015. So they started labeling it 4G LTE. It's kind of a stopgap. Just so you know the difference between 4G and 4G LTE. If you see that on your phone, 4G will always be faster. At the start of the year, however, Verizon started implementing its 5G network, and it's been rolled out in limited areas. They actually did showcase this in Korea. This was about 2 months ago, and the speeds it had were incredible. Just to show the difference, 5G standards is 500 gigabits per second. If you hearken back to my table, that's 10 to the power of 9 instead of 10 to the power of 6. That's a very, very large jump, just to give you kind of an understanding. It's the difference between about 1 million and 1 trillion. as far as speed is concerned. It's ludicrous. The difference is achieved through low latency standards. And what latency is the time that communication takes place over a network before a user can retrieve information. So it's not trying to get the waves to send information faster, it's about the computer processing that faster. So how fast can you respond to information you receive is really a good definition of latency. The goal of 5G is to reduce latency to the level of ISP latency. The level of latency that you experience at a home network should be next to nothing, as long as you're not connecting through a Wi-Fi connection. The goal is to get wireless connection speeds up to that level. So that's really what defines a 5G network versus a 4G network. Some additional standards include no worries of device crashing when using the wireless network. You can stream in 4K over your carrier's mobile network instead of having to connect to Wi-Fi or landline. You can separate a network from 4G and 3G infrastructure. So your 5G infrastructure is going to be completely different than your 4 and 3G, which means carriers can't really use existing infrastructure to carry it. And they have the capability of handling driverless cars and connected home products, as well as doing all of the things that 4G could do. So you could be in your Tesla being driven wirelessly while also streaming YouTube and checking your navigation on your wireless car, all at the same time using the same network and having no issues. That's the goal of 5G. And that's why it's going to take a while to really implement it. So how does it measure up? Just doing full speed comparisons. Using the same math we used earlier, we're going to transfer that same 60 megabyte file again. Through Verizon 4G, we already determined it's going to take about 9 seconds. Through your ISP at the slowest speed possible, it's going to take about 4.8 seconds. At 5G speed, that should literally take you a snap of a finger. It's less than 1/1000th of a second to transfer 60 megabytes. That's just phenomenal. There's no way a wired carrier would be able to match that, by the way, just because of the limits in the way they transfer data. That's really the goal of 5G, and that's why it's going to take a very long time to hit. Like I said before, because of these goalposts, there are a number of technical differences in the way that it operates. 5G operates in a higher radio wave frequency than is normally used. This means that the waves that are traveling travel faster overall between their crests and their troughs, the top and bottom part of the wave. What that means is there's a lot of available bandwidth because people haven't been using it. Currently, wireless carrier has to fight and license bandwidths. So because this operates in a higher frequency that isn't normally used, there's a lot available for carriers to buy. Current networks, however, are not equipped to operate within that bandwidth, which is why there's so much free. What that means is we're going to need all new towers, all new processing equipment, and all new signal generators in order to send out those signals. So that means that we need to do a lot of building in order to get 5G fully operational. Additional issues come with higher frequency waves, like they're more easily interfered with by solid objects and just noise in the atmosphere, which reduces the distance that 5G can operate on. So with a 4G network, you can send a signal from your local tower to a tower about, several miles away, really, with no issue. With a higher frequency wave, that reduces quite a bit. Instead of easily being able to transfer between like Cincinnati and Dayton, you'd be able to transfer maybe a third of that distance instead. And it's more easily interfered with, so that adds possible data loss into the equation. Like I said, it's not fully figured out yet. But that also means that it might not work inside of cars, buildings, railways. We're really not sure. Until the technology gets further ahead, it's going to be difficult to know where you're going to be able to get 5G. like I said, the main barrier is that it's just not fully figured out or implemented yet. Also, security needs to be addressed. We have a lot of security protocols in place for 4G networks, but we don't really have any for 5G yet. And if a hacker operates on 5G speed and you're on 4G, they're just going to dance circles around you. It means that security needs to be tightened on all of our networks. There's also currently no infrastructure in place to handle it. And because they operate on completely separate networks, a 5G device might not be backward compatible into 4 or 3G. And because of the limited areas that it's going to be released initially in, it makes me kind of hesitant to jump to a 5G device. I'm not going to lie. Like I said, this is going to be a difference in timing. 4G was initially laid out as a benchmark in 2008. It took carriers 10 years to implement 4G fully. 5G was literally just set in 2018, and it likely won't be widely available until 2020. And even then, I'm talking large cities. You won't see 5G speeds in between like Columbus and Dayton and Cincinnati for much longer. It'll probably be about 2022 is my estimate. It just means that it's going to be very expensive, very limited. I'd honestly wait about 3 or 4 years before you jump to a 5G phone. And things might move faster. Technology is always getting faster. So it's possible we might not have to wait that long. But honestly, it's just not safe to invest in until 2021. Like I said, because of the issues with backward compatibility, because of the limited rollout of the carrier networks, until there's more infrastructure, it's really probably not worth the price to jump yet. But it is very exciting for possibilities. Just because of the difference in speed, it's going to be phenomenal when it's rolled out. So it's something to be very excited about, but maybe not something to jump onto just yet. These were all my sources, by the way, and if you'd like to review them yourself, please send me an email at tlevine@crnstone.com. You could also call me at 513-487-5390, and I'd be happy to address any questions or comments. Also, please feel free to post a question here in the chat. I'll be online here for a little bit longer, so no worries. But thank you for attending 5G versus 4G, and I hope you have a wonderful, wonderful day. Oh, and don't forget to review if you'd like to review wired networks and just general internet networking, or if you were confused by some of the jargon I used. Last week's presentation will definitely help you. It was a project on Wi-Fi, and it's available through our Cornerstone Resource Center. So please feel free to watch and review.